Rotate matrix by 90 degrees. If our input matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9, the output will be 7, 4, 1, 8, 5, 2, 9, 6, 3. This can be used in rotating image by 90 degrees. The brute force solution would be to create another matrix of the same dimensions, that is n cross n, loop over the first row of the input matrix and assign the values in the first column of the solution matrix. Similarly, loop over the second row of the input matrix and assign it to the second column of the output matrix, and so on for the other rows. The time complexity of the solution is n cross n, and the space complexity is also n cross n, since we are using additional matrix to store the rotated matrix. In the optimal solution, we can reduce the space complexity to O1 by using the same input matrix to store the rotated matrix. We can observe in rotated matrix, rows becomes columns. If you had studied matrix in mathematics subject, you would know the transpose of a matrix changes the rows to columns, but the result of the transpose of matrix would not be the same as that of the rotated matrix. If you observe, the only difference between them is that in the transpose, all the rows are reversed as compared to the rotated matrix. So if after transpose we reverse each row, we have arrived at our solution. In simple words, the solution is first transpose the matrix, then reverse each row. The time complexity is still n cross n and the space complexity is O1. Merge overlapping subintervals. We are given a list of intervals. The first element of each list item is the start and the second element is the end of the interval. The problem is to merge overlapping intervals. For example, if our input is 1, 3, 2, 6, 8, 10, 15, 18, the output will be 1, 6, 8, 10, 15, 18. In the output, the first element 1, 6 is obtained by merging the first and the second interval as they are overlapping. And this is because the start of the second interval, that is 2, is less than the end of the first interval, 3. The solution is simple. We keep our solution, that is the merged intervals, in a separate list. We first sort the intervals, next we iterate over each interval and ask a question whether it can be merged with the previous interval of answer list or not. If it cannot be merged, we append a new interval in the answer list, and if it can be merged, we update the end of the last item. The time complexity is n log n plus n. Merge two sorted arrays. If our input arrays are array 1 is 1, 4, 8, 10, array 2 is 2, 3, 9, the solution should convert the arrays into array 1 becomes 1, 2, 3, 4 and array 2 becomes 8, 9, 10. All the smaller elements are in the first array in sorted order and all the larger elements are in the other array in sorted order. If we could have used extra space, we would make one array of size m plus n, where m is the size of the first array and n is the size of the second array. Sort that array, then assign first m elements to the first array and the next n elements to the second array and return them. The time complexity would be m plus n log m plus n, since we are sorting the array of size m plus n. The space complexity is m plus n. We can solve this without using extra space by moving all the smaller elements into the first array and keeping all the larger elements in the second array. Finally, sort both the arrays. Since both the arrays are sorted, we can move a smaller element to the first array by using two pointers. The left pointer is initially at the end of the first array and the right pointer is at the start of the second array. In other words, the left pointer points to the largest element of the first array and the right pointer points to the smallest element of the second array. If at any point the largest element of the first array is greater than the smallest element of the second array, we swap them. Finally, we sort both the arrays. The time complexity of the solution is n log n plus m log m, since we are sorting one array of size n and another array of size m, and space complexity is O1.